Statistics is all about collecting and analyzing data and then making conclusion by looking at those analysis. Now, why do we actually need data and why do we actually need statistics? Now, statistics is helpful in predicting future. Now, anytime whenever we are talking about predicting future, we are not talking about what will happen next or what will happen tomorrow. We are talking about a long future. What happens over a long period of time. We are never talking about the immediate future. We are always talking about long-term future. So therefore, statistics helps us understand what happened in the past and whether the same thing or similar type of thing will happen in the future or not. So we study the past to understand what might happen or how likely it is to happen in the future. So first of all, we'll talk about data. Now, data or any information will be of two types. One we call it as numerical data and the other we call it as categorical data. Now, any value that can be given a numerical value, any type of data that can be given a numerical value will come into numerical data, and any data that cannot be given a numerical value comes into categorical data. Simple example, numerical value, any kind of measurement that length, height, number of students, number of goals, anything that comes into numerical data. But data, if I say the colors, now colors cannot come into any kind of numbers. I cannot say red is 5 and blue is 7 or black is 10. So basically they become categorical data. Now in numerical data, discrete and continuous is pretty simple. Any value that will have some gap in each of those values, and usually we'll have the similar kind of gap. So we can say integers are basically 1, 2, 3, 4. So if I'm counting anything, number of cars in a particular day that passes through the road, so basically that becomes a discrete value. It's a number. So it will always be 0, 1, 2, 3, 4, 5 and so on. And even if I am counting in halves, or let's say my numbers are in halves, those are also discrete values because there is a gap of half between each values, 0.5. Okay. Now continuous data, when there is no gap between each value. So if my data is continuous, if I say data or a particular variable can take values from 0 to 1, any values between 0 to 1, basically there will be infinite values between 0 to 1. So basically whole numbers, or sorry, not whole numbers, real numbers. Now example for continuous data, let's say height. I cannot say I am going to grow from 5 feet to directly to 6 feet. Although we measure height in terms of discrete, we'll say 5 feet and 2 inches, 5 feet 8 inches, 5 feet 11 inches, 6 feet and so on. But that does not mean the height will grow from 5 feet 10 inches to 5 feet 11 inches. So basically what happens is that height is a continuous data. Similarly, length or age or any such kind of measurement, these are all continuous data. And let's talk a little bit about categorical data. Now in categorical data we have three types: attributes, nominal and ordinal. Now any kind of data that has only two categories, let's say yes or no or true or false, or any such kind of categories are called as attributes. Now these will have only two categories, so obviously these two will have multiple categories. Both of them have multiple categories, and nominal data has such categories that cannot be ordered. Again the same example of colors. If I say that I have let's say I have 5 colors and I want you to choose one of them. So none, I cannot order them that let's say blue is first, green is second, red is third, and so on. That order will not make sense. And ordinal has multiple categories, but it is ordered. So basically I'm talking about ranks. So let's say I took a test and some students, let's say the top student scored 95 out of 100 and the second student scored 93. The third student scored 89. Now see, the difference between their marks are totally different. So I cannot categorize them as discrete. But I can say the first rank, second rank, third rank, fourth rank and fifth rank. Now that means, or that assumes, that the difference between each rank might be very similar and actual case might be a little bit different, or actual marks will be a little bit different. So therefore we cannot categorize that rank into a numerical data, but we categorize into categorical data. So ordinal, similar kinds of ranks will have some order to it. Now anyways, this is not part of our portion because this is just an introduction to data. So we are only going to see the numerical data of discrete and continuous types, and we are going to see how we can do analysis on those data. Let's talk about discrete data, and we are going to see continuous data in chapter 3. Now basically, collection of data is not again part of our course. Our course starts from analyzing data. Now what kind of analysis can we do? Now the most important, or let's say the first step of analyzing data is finding its average. So first is averages. Now basically we have 3 kinds of averages. One is mean, second median, third is mode. So first, let's say we are talking about mean. Now what is mean? Mean is the arithmetic average, or what we do is, if let's say I am talking about mean, x bar will be equal to sum of all values, so summation x upon n. N is the total number of values. Now in mean, x bar is used to denote sample mean, and mu is used to denote population mean. Now in formula, basically x bar and mu does not have any kind of difference, but there is a difference between what a sample is and what a population is. Never, let's say I am studying something, I may not be able to get complete data. Let's say if we talk about elections. Now in elections, we prefer to take everybody's vote. So that will come up to population, or we are going to check for the whole population. Now, but if you see the news while the elections are going on, you are going to see opinion polls and you are going to see exit polls and such stuff. Now what do they actually do? They are not going to everyone and asking for their vote or whom they are going to vote. So what they do is, from let's say each kind of district or each city, they are going to select a few people, and then out of them they are going to make a sample. So that becomes a sample mean, and after that they'll do analysis on that sample and try to project that over the whole population. So it might be a little bit different, but more or less if the sampling is done well, then the population mean will be very close to our sample mean. Therefore, we use sample a lot to know about the whole population. Now, if we have, let's say, frequencies, we just change this into summation fx upon summation f, or I can just write it as n. Okay, summation f, or I can write this as summation f or just n. Now what is f? F is the frequencies. So if I take an example, let's say my variable x can take values from my sample. The number of tens that I got are, let's say, 5. I took a sample of, let's say, total 100 values, out of which there were 5 tens, there were 15 20s, there were 35 30s, 25 40s, and 20 50s. So basically this becomes our sample of these values. Now if we need to find mean, we are going to use simple this formula, summation fx by n. Total number is nothing but adding all the frequencies, that gives us 100. Now summation fx, you can just write here, your fx will be just multiplying these values. Sum of all these values are basically mean x bar is going to be 3400 by 100 or 30. Now there are some restrictions, or you can say properties of mean. Now mean will always be between the lowest value or the highest value. So mean cannot be beyond these particular values. Mean will always be inside our limits of this variable. But the problem with mean is that it might not be an exact value. Now you can see we have a value 30, we have a value 40, but the mean is coming out to be 34. Let's say if this was number of people and I said it was 10, 20, 30, rather than 10, 20, 30, 40, 50, I am saying 1, 2, 3, 4, 5. So I am going to get my mean as 3.4. Now if I am saying the average value is 3.4 people, now that does not make sense. So many times finding mean is not going to give us the exact value, but it is saying averagely how much is this going to happen. Or let's say if I am saying I am paying you 1 rupee, 2 rupee, 3 rupee, 4 rupee or 5 rupees every time, let's say something is going to happen, and these are the possible ways that it can happen in every 100 ways, then you are going to get 3.4 rupees averagely every single time. So if you play, let's say 100 times, so you are going to get 340 rupees. Now the second analysis that we do, nothing but median. Median is another average. Now what does median do is, it tells us the central value of the whole population. Now basically if it is saying the central value, that means 50% of the population are going to be on one side and 50% on the other. So basic property of median is that it divides the whole population in half. Formula, if I just write it as m, is nothing but I find the n by 2th value. If n is even, and it will be n plus 1 by 2th value if n is odd. So here n is even, here n is odd. So we will find this particular value. Now in this question basically n is 100, so n by 2 is going to be 50. We are finding the 50th value. For that what we do is we find the cumulative frequencies. So I'll just write CF here, cumulative frequencies. And what is cumulative frequencies? It is frequency less than or equal to that particular value. So less than equal to 1, I have only 5 values, but less than equal to 2, I have total 20 values. Less than equal to 3, I have 35 plus 15 plus 5. So 55 values. Then I have, and I can find all the others, but basically we needed to find, or let's just find all the others. So less than equal to 4, we'll have 25 plus 55, get 80, and then 100. So this becomes our cumulative frequencies. Now to find median, what do? We actually find that value that is going to be the 50th frequency value or 50th value in our population. Now here basically if you see, up till 20 values, the value were either 1 or 2, and from 21 to 55 all the values are 3. So basically the 50th value is also 3. So this becomes our median. Here I write median is 3. Now one of the advantages of median over mean is that it gives us the exact value. It will never be a let's say value between these two or something else. So therefore median sometimes is preferable over mean, and other than that, a disadvantages of mean is that mean will be affected by extreme value. Now if instead of 5, if I keep 50 here, now this becomes an extreme value. All other values are 1, 2, 3, 4 very let's say ordinary values that are near to each other, but this 50 becomes an extreme value. I have not changed the frequencies. Now that will definitely affect the mean here, but it will not affect the median or the mode that we are going to study next. So therefore this is one of the disadvantages of mean, that extreme values will affect mean a lot and it will shift the mean towards that particular extreme value. If this extreme value that I took 50 here, the value would have been shifted somewhere between 4 and 50, and if I take a negative value, let's say minus 50 somewhere, the value will be shifted towards that particular value. Now if you have studied another way of finding median, especially when we have group frequencies, so we are not going to use those formulas. Why? Because those require some kind of approximations, and here we are never going to use any kind of approximations. So you will not find us actually using group frequencies either. Now third is mode. So basically mode is nothing but the highest value that we can, or highest frequency that we can find. So the highest frequency here in this particular term is 35, so our mode will be 3. So mode becomes, again mode has some advantages. First advantage, it is not affected by extremes, and secondly it can give us the highest limit that we can find. So 35 is the frequency that is the highest limit. So let's say if I wanted to know how many people I can accommodate at a given time, and let's say this is different classes that I am taking, and these are the number of students that come in that particular class. So basically what I can see is the mode is going to give me that the size of the class should accommodate at least 35 students. Among all averages, that is mean, median and mode, mean is the most widely used because this can be used for further calculations. Median and mode cannot be used for further calculations just because they don't consider all the possible values of our variable. So therefore mean will only be used in further calculations, and that is why it is used in most of the calculations. Now averages might not be enough to tell us about a data. Now average just tells us the first degree, or let's say first analysis. Now sometimes let's say there are two batsmen that, let's say, last 5 matches, or let's say last 4 matches of a particular batsman has scored 50 in his each match, and there is another batsman that has scored, let's say, 100 and 0. The average score of each of the batsmen is actually 50 every match, because there have been 4 matches, and this average will be 200 by 4. This will also be 200 by 4. So basically the mean of both of them are exactly same, but we can see there's a difference. Now if you want to pick a, let's say, batsman that will be more reliable, you would pick batsman 1. You are not going to pick the batsman 2. Now definitely this person is more reliable to score a 50. This person is not that reliable to score 50. Now for that, what we do is we use our second analysis and we find the variance. Now variance tells us about the reliability of our data. Now simply variance, we write it as S square or sigma square. There are two notations for our variance. S square is sample variance and sigma square is our population variance. There is a difference between formulas of sample variance and population variance. Now what we do is, our S square is nothing but 1 by n minus 1 summation of x minus x bar the whole square, and sigma square is 1 by n summation x minus x bar the whole square. So basic difference is just n minus 1 and n. Now why do we have two different variants? We are going to see that in chapter 9. Then right now we are going to see what or how we can do analysis on this particular variance. Now first of all, variance is talking about how much each value is averagely varying from the mean. Therefore we are finding the deviation x minus x bar, that becomes deviation, and we are squaring those values. Why? Because summation of x minus x bar is going to be 0. Now simply there are few properties of summations that we should know. First of all, if there is addition or subtraction in between, we can give individual summations. So we can write this as summation x minus summation x bar. Then if we have a constant multiplied to a variable, if I had, let's say, 5x here, I can take 5 outside of the summation. So basically right now this x bar is a constant value for all values of x. So I can write this as summation x minus x bar summation 1. Now summation 1, summation of a constant would be nothing but, like, summation 1 would be 1 plus 1 plus 1 and so on till n number of terms. Here we are assuming x is going from 1 to n. So basically we are adding this n times. So we are going to get nothing but summation x minus x bar x bar n. And if you see the formula of x bar is nothing but summation x by n. This becomes summation x. So the term becomes 0. Now what we are going to do is we are going to use similar rules or same rules of summation to find or expand this particular term. Now for that, let's say I have summation x minus x bar whole square. I can write this as summation x square minus 2x bar x plus x bar square. Then I can just write this as summation. Now I can give individual summations because there is addition or subtraction in between. So I'll get summation x square minus summation 2 x bar x plus summation x bar square. Now this 2x bar is nothing but a constant, as well as this x bar square is a constant. So I can write this as summation x square minus 2 times x bar summation x plus x bar square summation 1. I can write summation x as nothing but x bar into n, because x bar is nothing but summation x by n. I can write this as summation x square minus 2 x bar into n times x bar plus this becomes n times x bar square. This becomes summation x square minus 2n x bar square plus n x bar square, or finally summation x square minus n times x bar square. Now we can substitute this here. We are going to get 1 by n minus 1 summation x square minus n times x bar square. I'll just write it here clearly, 1 by n summation x square minus n times x bar square. So this bracket will be same here. Instead of 1 by n, we will have 1 by n minus 1. So both of these formulas of s square and sigma square are important. Even this as well as this. Now 99% of the time you will find we will be using this particular formula, because in the question usually they give us these values, summation x square n, and then they will give us summation x, from which we can find x bar. So what happens is we will directly use these values. So therefore you should remember this particular formula. Now another measure of deviation is standard deviation. Standard deviation, if I write it as SD of x, is nothing but root of variance of x. So basically for sample standard deviation, s becomes our sample standard deviation, that will be nothing but root over these values, and for population sigma becomes our standard deviation, and that will just be root over this value. Sometimes our second order analysis, that was our variance or standard deviation, is also not enough. There might be some data that have the same mean as well as the same variance. Now let's check this particular example. Here again average is 50, here the average is 50, and if you see the variance will also be the same, because they are basically flipped values of each other. Now averagely each value is equidistant from the mean. Now what do we do then? Now basically there is a difference between these two kind of batsmen. Now if I ask you which batsman would you prefer to bat next or take into your team, you would definitely see that last two games this particular batsman did not score any runs, and this particular batsman has scored 200s back to back. So you can say that this particular batsman is in form. So simply you are going to choose this over this particular batsman. Now how do we analyze this particular thing? Now this is called as skewness. So our next analysis is skewness. Now the formula for skewness, first of all there is no symbol for skewness, we just write it as skew of a particular variable x. So skewness is nothing but 1 by n summation x minus x bar whole cube. This becomes our formula for skewness. Now any formula, we always write it as non-frequency formulas, but any formulas, if you want to convert them into frequency formulas, all you have to do is put an f after summation. Everywhere whenever you find a summation, just put an f after it, and that becomes a frequency formula. Now back to skewness, we have this particular value. Now skewness tells us whether the data is concentrated at the starting of the particular distribution or at the end of the distribution. So starting value has more data or the end value has more data. So that kind of value will tell us about, or that will be shown by skewness. Now basically, if my data is concentrated more towards the beginning of my values, then this is called as positively skewed. If my data is basically not let's say big at the beginning or not at the end, or let's say it is more distributed properly or symmetrically, we call it as zero skewness or symmetry. This is more or less symmetric. And if the data is more concentrated towards the end, then we call it as negatively skewed. Now this is also shown by this value. If the skewness value is positive, then we will find the data to be somewhat like this. It will be positively skewed. If this value is more or less very much near to 0, then it might be a symmetric value. And if this value is negative, then we might find a value to be more towards the end. I'll just make this diagram more believable, like negatively skewed. So now we can basically expand this similar way. We expanded the variance. I can give individual summations and I can take the constants out. So I can say this is summation x cube minus 3x bar summation x square. 3x bar is nothing but constant, plus here we'll have 3x bar square as constant summation x, and we'll get minus x bar cube summation 1. The whole x bar cube is a constant here. Now this is nothing but summation x cube minus 3x bar summation x square, and I can write summation x as n times x bar. Summation x is nothing but n times x bar, so this becomes 3n x bar cube minus this will be nothing but n x bar cube. So our final answer is nothing but summation x cube minus 3x bar summation x square, plus we'll have 2 times n x bar cube. Now you are not expected to remember this formula, because very rarely you will find question about skewness where you will have to actually expand and find this formula. So basically just remember the way we are going to expand and remember this particular form. Sometimes our mean, variance, skewness might not give us everything about our data. So we might go for other analysis. So the mean becomes our first degree analysis, variance becomes our second degree, skewness becomes our third degree analysis. Now if you want to go to fourth degree, fifth degree and so on, so we can actually find that using this formula. There are no names for the 4th degree, 5th degree and 6th degree analysis. We call them as moments. Now either you can say 4th moment or you can say 4th degree moment. It's the same thing. So we just write it as 1 by n summation x minus a whole raised to r. Now first of all, the exceptions here are going to be sample variance as well as mean. Now mean is nothing but x where a is equals to 0 and r is equals to 1. So if we have a 0, r 1, that is nothing but that gives us mean. If we have a as x bar and r as 2, this gives us population variance. If we put a x bar, r as 3, we get our skewness. Basically, there is a kind of variance that cannot be found using this, that is our sample variance. Therefore, they do not mention mean and the variance to be moments. They say they are the exceptions. We start from skewness. Now, first of all, a can be any value, and we call their moments around that particular value, because we are actually seeing the deviation and basically powering that deviation raised to r. Then we are doing the summation and then we are taking the average of that particular value. So basically this is nothing but a moment around a. Now if we have a is equals to 0, we will say it is the moment around 0. Now if we have x bar, we call it as central moment. So this population variance, skewness, these are called as central moments of 2nd degree, central moment of 3rd degree. The other kind of analysis that we are going to see is finding quartiles. Now the term quartile comes from quarters. Quarters is nothing but 1/4 of something. Now quartiles are those values that basically divide our full data in 1/4. So basically, if let's say this is our data, then now these are not dividing our values of x, these are dividing our population into 1/4. So therefore this much portion, this particular portion, I am assuming is equal to this particular portion, equal to this particular portion is equal to this particular portion. So basically these values we call it as q1, q2 and q3. q1 will divide our population in 25 and 75%. q3 will divide it into 75 and 25%. q2 will divide into 50 and 50. Basically it is nothing but mean. q2 is nothing but mean. So we can just change this, sorry, not mean, median. I mistake. It's median. So q2 is nothing but median. So we can change that into median. So all we do is find q1 and q3. So we say q1 is nothing but n by 4. It divides our whole population in 4 parts. When n is even, we say n plus 1 by 4. N is odd, and they have also given us another formula, that is n plus 2 by 4, again when n is odd. Now you can solve by either of this and you will get the answer to be correct. You will definitely get different answers, but both are acceptable answers. And for q3, we will say either we can directly do 3n by 4. Again, if n is even, we can do 3 times n plus 1 by 4. Again, if n is odd, or 3n plus 2 by 4 if n is odd. So quartile is actually, each quartile is talking about where our particular 25% of the data is. Many times we do not need the extreme value, so we are more concentrated about our between 50%. So that value is called as interquartile range. The interquartile range is nothing but Q3 minus Q1. Simple formula. Other than that, we have another range. Our range is nothing but the highest possible value, highest value of our variable, not the frequency. So highest value minus the lowest value. So if the data is between 0 and 100, then basically the highest value is 100, lowest value is 0, so our range becomes 100. Frequency might be anything. Interquartile range will find Q3, will find Q1, and that becomes our interquartile range. The data is always best represented when it is a visual representation. Now whenever you are doing some analysis, now you might be good in statistics, but the people who you are going to present that data to might not be very good at statistics. So the data, if it is visual, becomes much easier to understand. So for that, basically the visual representations, we have many different ways to visually represent. First of all, bar diagram. Now simply what do we do in bar diagram? We take our variable x and we'll plot it in x-axis, and here we'll plot the frequencies. Y-axis becomes our frequency. So we'll just make bars and that becomes our bar diagram. Now in bar diagram, basically the length matters. This represents the frequencies, but the width really does not matter. Width is just a representation of something. It's just easier to see. That is why we use some width. But the width does not matter. The actual values of frequencies are in the lengths of the bars. Now other than bar diagram, what we see is histogram. Now in histogram, basically we are going to use length as well as the width. Now in histogram, what we do is we usually represent continuous data or group data. Here, if my data between 0 to 10 has frequency, let's say 20. So between 0 to 10, the values are 20. So what we do is we actually divide the number of frequencies by this particular width of our group. So if the width of our group is 10, so I'll just divide it by 10, I am going to get 2. So let's say that becomes our value. So here we are representing x, and here we say we are representing frequency density. So here we are not representing frequency, but we are representing frequency density. Now let's say between 30 and 50 there are not many values, so I can combine those groups. Now if I combine those groups, let's say there are total now 50 values. Now if there are 50 values, now it is over 20. My range of this particular set, or you can say this particular group, is now 20. So I'll divide it over 20 and I'll get 2.5. Basically my frequency density becomes 2.5, and I'll represent it like this. I'll just make some diagrams, and this is how our histogram is actually represented. Now sometimes what we do is we represent, or we just join the midpoints with the ends. And this particular line is also called as histogram. So we are actually joining the midpoints of our group with the ends, and this shows us an approximate distribution or a graph of how our values are going up and going down. So now if we need to find frequency just by looking at this histogram, what we'll do is we'll just calculate the frequency density, the length, and then multiply with the width of our particular group, and then we'll say that becomes our frequency, length into width. Now let's talk about line plot. Let's say this is our data points. We have 2s, 5s, 7s, 9 and so on. Now how would we represent it when we are talking about line plot? So what we do is we draw a line and we have all the possible values in here, and we'll represent our particular values with dots. So let's say approximately 2 will be here, 5 will be somewhere here. I have 3 5s, so I'll just make 3 5s one above the other. Then I'll have 7, 2 7s, then I have 9, then there are 5 11s. So approximately our data will represent a line plot somewhat like this. Now this gives us a brief idea about how our particular distribution might look. It talks about, let's say, the shape of the distribution. Now if we can find mean, we know where the mean might be, and then we can talk about the variance, the width, how much is it far, each value is far away from the mean. Now if I have data that looks something like this, and let's say my mean is somewhere here, now I can say that the values are very close to the mean. Most of the values are very close to the mean, so I'll say the variance is not much. But if my data looks something like this, now this, all the values are spread over a large value of, or large area, so I can say that the variance is going to be much more. There's a more spread. Then we can talk about the skewness just by looking at the shape. Even in this looks more or less very symmetric, but if we want to pick, this particular portion has more values than this particular portion. So I can say it is more positively skewed than being negatively skewed. Again, if the data representation is very clear, if it looks something like this, we can say it is positively skewed. If it looks something like this, we can say it is negatively skewed. So just by looking at the line plot, we can not only see the representation of the data, but we can talk about the variance as well as the skewness of these particular data. So many times you will find a question where they'll give you two sets of data. They'll ask you to draw a line plot and they will ask you to comment on it. So they are expecting you to talk about their variance and talk about their skewness. Compare them and say one has more variance than the other, or one is positively skewed, the other is maybe symmetric or maybe negatively skewed, or something like that. So they are asking you to analyze it, and they might give you a small question where, let's say, we need less variance, we need more reliability. So which one would you pick? Next representation is box plot. In box plot, what we do is we draw the whole range. This will be my lowest value, this will be my highest value, let's say 0 to 100, and then we draw a box. This box is representing my Q1, Q3, and let's say there's a line that is Q2 or our median. So basically this is all that you need in a box plot. You will need the range, the minimum value and the maximum value of a variable. Then you will need Q1, Q3 and Q2. So you need only the quartiles to draw a box plot. The box plot talks about the data a lot. Again, now if you see, this particular first 25% is spread over large values than, let's say, this last 25%. So just by looking at this box plot, we can say that it is more negatively skewed. Similarly, I can say this particular 25% is more spread over more area than compared to this particular 25%. So even the middle 50% is more negatively skewed. We can talk about median. Again, just by looking at this, we can say that it is negatively skewed. This 50% is spread over more area than this 50%. Then, if I have, let's say, one box plot that looks something like this, and the other box plot, let's say, looks something like this. Now we can say this is more symmetric and this is positively skewed. Other than that, just by looking at the boxes, we can say the data is more evenly spread here, but here the data is more concentrated towards this mean. So you can median. So basically, your 50% of the data is spread over a very small region here, and here your 50% of the data is spread over a large area. So you can talk about the variance. So you can say the variance of this is much less than the variance of this. So again, this might be more reliable data than this because it is not varying that much. Let's talk about stem leaf diagram. I have taken similar data that we took in line plot. I have just added a few more points. Now, in stem leaf diagram, basically what we do is we draw a straight line, and this part of the line is going to be the stem and this part is going to be the leaves. First of all, what does stem represent? Now, stem represents the values in a way, or you can say the groups. So if I write it as, let's say, 0, 1, 2, 3. So basically this 0 is representation of all values between 0 and 9. This 1 is representation of, let's say, 10 to 19. This would be 20 to 29, and this would be 30 to 39. So basically this 0, 1, 2, 3 is the representation of a group. Now these values are nothing but our leaves. So let's say I have 2, 5, 5, 5, 7, 7, 9, 9, 9. All of these values are between 0 and 9. Let me do one thing. I'll just reduce a few values. I'll make it 1, 5, 1, 7 and 3. I'll just write it as 5, 7, 9, 9. Then this 11 to 19, all of these values are going to be represented by this particular one. Now I know if I just see this one as my stem, I know the values are in between 10 and 19. So basically while we are writing our leaves, we don't have to represent that. So basically 11 will be written as 1, this 11 will also be 1, this 11 will be 1, this 11 will be 1, and this 11 will also be 1. So basically there are 5 11s. I have just written 5 1s. Then 13, 13, how many 13s do we have? 1, 2, 3, 4, 5, 6, 7. So 3, 7 3s, then we'll have 4 7s, then 2 19s. So basically this one already represents that these values are in between 10 and 19. So we don't have to use that particular one to represent that this value is 11, this value is 13, this value is 17, and this value is 19. Then next, for 20 we can just write 0, we'll have 2, 2, we'll have 7, 7, 9, and lastly we'll have 0, 1, 7. This is nothing but our stem leaf diagram. Now in stem leaf diagram, you have to know one thing, that just by looking at this we can know about the approximate distribution of this particular data. So we can say that it is peaking at, let's say, 1, and you can talk about the mode, or let's say our mean will be somewhere here or something like that. We can take average and find the mean. We can count the values and find median. So if we want to find median, total, let's say there are 32 values, so 16 will be our median. What I'll do is, so basically this 3 is our 16th value, so 13 becomes our median. So this is how we can count median. We can find Q1, we can find Q3, everything. Other than that, we can talk about the skewness, we can talk about the variance of this particular data. So therefore, stem leaf does not only represent all the possible values, but it also basically talks about skewness, variance, median, mean, and everything. One of the thing about stem leaf diagram, this should always be in ascending order. Even if your data is not in ascending order, this should always be in ascending order. Now, this was just two-dimensional data. Maybe the data is not only of two, let's say, values, it is in hundreds or thousands or something like that. So if you have, let's say, 171 and 173, 174, and so on. Now what you can do is, either your representation might be 17, 17, 17, that might be your stems instead of 0, 1, 2, 3. If let's say the data is between 150 to 190, so I can keep 15, 16, 17, 18, 19 to be my stem. But what if the value is between, let's say, 0 to 1000? So then what we'll do is, we'll take our stem to be 1, and then let's say you have 237, so 2 becomes our stem, and 579, this becomes our stem, and so on. So basically, first number becomes our stem, and leaf will only have one digit. Leaf will never have more than one digit. So therefore, we'll have to round this off, and this becomes a 7. Round this off, this becomes a 7. This becomes a 7. This 4. This 8, and so on. So you will round off to get your leaf. So there we might lose a little bit of data, but that is okay. It's just a visual representation. In your examination, you will find problems about combined mean and combined variance. Now, what is a combined mean? Let's say if I have two different datas and two different, let's say, regions, and I know their mean, I know their standard deviation, I know their let's say total number of people in that particular areas. So if I want to combine that into one and find the combined mean and combined standard deviation. So let's say I know x bar 1, x bar 2, I know S1 square, S12 square, and I know N1 and I know N2. Now if we need to find combined mean and combined variance, simple formula for combined mean is nothing but N1 x bar 1 plus N2 x bar 2 by N1 plus N2. How do we get this? X bar c, I'll write as summation xc upon nc. Combined sum of all values of x. Combined sum of all values of x, it is a representation of region 1 and region 2. So I can say it will be summation x1 plus summation x2, and total number of values in combined mean will be nothing but n1 plus n2. The summation x1 is nothing but n1 times summation, n1 times x bar 1 and this becomes n2 times x bar 2 on n1 plus n2. So this becomes our combined mean. Now what if there were 3 regions? This becomes plus n3 x bar 3 plus n, and so on. You can go on adding as many regions as you want. Combined mean will be this particular value. Now what about combined mean, combined variance or combined standard deviation? For that, let's say our variance SC square is nothing but 1 by n minus 1. Now 99% of the time you will find your chapter 1 questions to be of a sample. It will not be of the whole population, because they are going to give you a little bit of value and they are going to specify that that's a sample. So therefore they are going to ask you about the sample standard deviation and sample mean. So basically sample standard deviation or sample variance we'll be able to find using this particular formula. Summation, I'll say xc square minus nc x bar c. Now we'll usually find our combined mean. NC we know. The only thing we don't know is this summation xc square. That is nothing but square of all the values in both regions. So square or sum of squares of all the values. So I can say summation xc square is nothing but summation x1 square plus summation x2 square, and using the similar formulas of S1 square, I'll have this here, I'll have summation x1 square. What I can do is I can just multiply this n minus 1 here and then add this particular value. So summation x1 square will be nothing but n1 minus 1 s1 square plus n1 x bar 1. This is square, this is also square. And similarly summation x2 square will be n2 minus 1 s2 square plus n2 x bar 2 square. Now you can use this value in this particular term and you will get your answer. And if they ask you standard deviation, just take root of that particular value, you will get your standard deviation. Other than that, you will find such type of questions where they'll, let's say, eliminate one value. If they eliminate one value, what will happen? Let's say my old mean was x bar and are eliminating, let's say, 70 from that particular value. So I can say my new x bar will just be my summation x minus 70. I will be removing 70 from my summation x, so it becomes summation x minus 70 upon my new value will have n minus 1. One value will be removed from that particular value. Summation x is nothing but n times x bar minus 70 by n minus 1. This becomes our new variance. Similarly, you can do that for standard deviation also. This was our new mean, sorry. And what if they are replacing a value? If they are replacing a value, you will just subtract the old value and then add the new value, let's say 90, and then n minus 1 will just be n, because we are basically replacing that value. We are not removing it. These are the usual types of questions that you are going to get from chapter 1. That is going to be either of combined mean and combined variance, or you might get of finding the new mean from these types of